Ladies and gentlemen, my name is Joni Utash with Adaptive Corporation, and I would like to welcome all of you to our webinar today. Our presentation is titled Reverse Engineering and Data Validation for CATIA V5. Today's event is focused on selecting the right tool for the job, where does CATIA fit, and an explanation of the process. Your presenters today will be Larry Kuehn of Adaptive and Steve Margia, our application specialist. At the conclusion of the webinar, the presenters will be taking questions from the audience. To ask a question, simply enter it into the GoToWebinars chat window at the bottom right-hand corner of your screen, and we will queue up your questions at the end. We're now ready to begin. I'll hand over to you, Larry.
Thank you, Joni. As Joni said, my name is Larry Kuehn at Adaptive Corporation. I have been working in the metrology industry for many years with a heavy focus on CATIA products, mainly around inspection and manufacturing, with a strong emphasis on aerospace defense supply chain, with a pretty good expertise in model-based definition and all the best practice applications that go along with it. We are also joined today by Steve. Steve has extensive experience in reverse engineering and Class A surfacing in multiple CAD platforms.
Good afternoon, good morning, gentlemen and ladies.
Thank you, Steve. Adaptive provides software and service to the automotive, aerospace, and defense industry based on the Dassault System software. We work with companies in support of their quality and manufacturing initiatives and help introduce them to other approaches to reduce time and cost. Our goal is to help you save money, improve quality, and meet your customer demands on time and budget. Here is kind of a snapshot of our customer portfolio. We have small and large. Our customers range from a small and large and span a variety of industries. There are three takeaways there are three takeaways we think will be meaningful to each of you on the call today. Our first takeaway is selecting the right tool for the job. By that, we are referring to understanding your customer requirements, deliverables, and downstream applications of the data once it has been scanned. Our second takeaway is, where does CATIA fit in the process? Many of you on the call may be wondering what additional tools exist in CATIA to help create the deliverables. Our third takeaway today is, what results can I expect from the process? Many of you may wonder if the result of the process is a simple surface model or an unintelligent solid, or am I getting an intelligent solid with history? There are a variety of options when it comes to scanning devices. The secret is understanding the task at hand, and then what do I want to do with the scanning results? Options include scanning part to reproduce the math model of the part for manufacturing processes and downstream applications, scanning the part to create tooling, scanning the part for part validation or inspection. Does the physical part match the CAD data model? The answer you select to the above considerations may influence your approaches. What we're seeing in this picture here is, on the top left is a laser tracker, which is used for very large parts that can scan up to and take data up to 50 feet in any direction. Portable arms, coordinate measure machines, hand scanners, and photogrammetry type scanners. So there's a wide range of ways to collect data. And they all have their applications and importance. Next, we want to talk about software. There's many different types of software that can be used to gather the data. What we're showing here is some of the leaders in software. They all have their strengths. They all are very good. A lot of times software will come with the purchase of a scanning device. They interface well with most scanning device. We use Verisurf software. It is industry standard at Boeing and Northrop, and it's used for validation and reverse engineering. A lot of our customers use Verisurf in the aerospace industry, so this particular example, we're going to be taking the data with Verisurf. But all these softwares are seen in the industry and used in the reverse engineering process. As you can recall from my earlier comment, the best probing scanning method depends on the task at hand. Here are a couple examples. This is one of the most important takeaways of this webinar. Different parts, different results that you want depending on how you want to take data. On the bottom left, we scan the part and we use the point cloud. There's about 400,000 points that were gathered here. This part, it's all contour, flimsy, no datum features. Scanning point cloud method was the best approach for this particular part on the left. On the right, the wind blade is almost 80 feet long. The tolerance is not as critical. The best approach to taking the data on this was using a laser tracker and doing cross-sectional cuts, and we took points and splines about every 2 feet on this part, and then we surfaced in CATIA from there. So depending on the part, depending on your end result, is the approach that you want to take for gathering your data. So that's a very important part of the initial part of reverse engineering. Another important part that the technician wants to keep in mind is it is extremely important for the scanning technician to organize data before passing scan file to the designer. What I mean by this is when we organize the data and as we're gathering the data, in CATIA we can control the data in different geometric sets. We can change color as the different part of the job is being scanned or measured, and we can put instructions into the CATIA model for the design guy to be able to clearly follow. So colors, layers, sets, and instructions is very important as the technician passes the data on to the design engineer. What we're seeing here is we're going to start our reverse engineering process. We have a contour part on the left that has no flat surfaces. Everything is contour. Multiple areas on the part that change. We figured the best approach to this was to use a ferro arm and a line scanner. On the top right, we gathered the data in Verisurf. We collected thousands of points, and we filtered it in Verisurf, and then we output the data into an ASCII format that's for CATIA to import the data. Where does CATIA fit in the process? We're going to start out on the top left of each one of these slides. I want everybody to see that we're changing CATIA workbenches as we go through the modeling process. I believe we touch 5 different workbenches in CATIA as we do the reverse engineering and modeling of the scanned data. We start out with the digitized shape editor to import the point cloud. Next, we clean any erroneous or wild points and simplify the data. So it's inherent in scanners or measuring devices. Some of the data you're going to get what I call noisy points or erroneous points. You need to have mechanisms to be able to clean the data and organize it. Here we are parsing the cloud to local areas to begin the surfacing process. That's another, more tools in CATIA. We use the parse data to create any primary surfaces. We get a good approximation, and then later we clean up the surfaces. So we're at another workbench. We work our way around the cloud and create local patches that encompass and represent the point cloud best. Again, creating best fit surfaces that we'll clean up later. We use additional tools and various workbenches to tweak the surface of an initial rough surface creation. We match the data within specified tolerances. Here we have control points that we can manipulate the surface as we go. Here we see a completed surface through the given points. The process is not fixed, as there may be curves that drive the surface as part of the initial input. Mylar's drawings may also be available to help locate critical features that assist in the final modeling. So not only do we scan the data, we might have other engineering standards and direction that we can tweak the surface even more. And that's all available inside CATIA. The final surfaces are taken into GSD to create an edge, flange, and ribbon for part of the processing and manufacturing. So at this point now we're in the generative shape design workbench, and being able to extend your model surfaces is very critical for downstream applications, for trimming, filleting, things like that that you might want to work with on other parts of the scan model. So several solid bodies are created to represent the final manufactured part, as well as the tool that will be created for the parts. Here we see that we designed the shown part, we mirrored it so we can manufacture and produce multiple left and right part. Benefits of using CATIA. CATIA V5 provides us a suite of tools that are used for point cloud importing, modification, surface creation, solid creation, analyze, machining, and manufacturing. A complete unified platform for beginning to end of the design process. Higher level accuracy, cleaner surface and edge boundaries, a history tree inside CATIA to capture design intent, parameterization of the design of the final model. File management becomes easier because we're in one platform. Interoperability between CATIA surfaces and CATIA composite design workbenches. Because that we're doing the design in CATIA, we can utilize the other CATIA workbenches to place our part into assemblies, or to use other workbenches like the composite design workbench. And then we do not have to deal with translating data. We do not have to worry about STEP or IGES because we're doing our design inside CATIA. The importance of using the right device. In summary, the importance of using the right device, scanning device for the job. CATIA is critical to the process to create the solid model. The final CATIA V5 model will be within the specified allowable design intent. Then I'd like to show the part that we just saw in the CATIA V5, and you can see that we have a history of the design. So our model is an intelligent model that can be changed and modified as needed. This is a little different than if we just had a solid model with no history. Next steps. Use Adaptive for your next reverse engineering project. If there is any immediate reverse engineering projects that may be coming up, we would love to talk to you about going in conjunction with you and performing your scanning and helping with your modeling. Use Adaptive to define your processes. Everything that we showed here, we can come in and we can help you with defining your processes for data collection and modeling inside CATIA. And we also offer an inspection first article process. We can come in, we can have equipment, we can offer first article inspection and the software that we provide to do first articles. Joni, could we open it up to any questions that may?
Yeah, I have a question, Larry. The question is, how do you create a solid from all of the surfaces you created in generative shape design?
Okay, I'm going to defer that question to Steve.
All right. Well, there's several solids that are the final resultant of those surfaces. We need to basically, once we get in this case we had part ribbons on the end. Those ribbons were critical to place in there to help with the runoff on the machining of the actual tool. They're not critical to the actual part. So we have to take things in sort of an iterative process. We have to generate the part, we have to generate ribbons or runoffs, or if it's a composite, we have to create the layups and the ramps. And once we have all that data, we can take that data, simply switch from one workbench to the next, and then if in this case this is a composite part with a constant thickness, we can just simply apply a thickness to the part. For the tool, we created those ribbons on the side so we could actually machine that tool out. So what we do is basically on that tool create sort of a tool base, sort of a mold base, and pad that out, and then split it back to the surface with the ribbon or the runout in order to create that final tooling surface. So there's a few bits of the tool that or the final manufacturing process that are basically being simulated within CATIA. So, you know, again, depending on the process that you're working in or the type of material you're working with, you know, if you're doing a reverse engineering of injection molded part, there's other workbenches that allow for quick, easy, and fully manufacturable parts like functional molded part, the composite design workbench. So it's based off of what the individual company or corporation or person is looking to do as well.
Hopefully
Okay,
that
thank
answered
you,
the
Steve.
question.
I do have one more question. The question is, what is the level of accuracy of the final part?
I'll get this one, Larry. Well, when you're talking about accuracy, there's several factors that play into it. We've got the scan accuracy, which depending on the type of scan and how large the part is, and actual temperature of the day, the sun shining on the part or not, can affect the actual final level of accuracy. But once we get it into CATIA, you can basically model to an extremely high level of accuracy. If you want, depending on, again, how large the part is, you can get things down to 20,000, 10,000. If you're dealing with canonic shapes, planar shapes, cylindrical shapes, things of that nature, toruses or cones, then you can get that level of accuracy down even higher, again, because we're dealing with a canonic shape. If you're dealing with like outside of sheet metal, like a belly fairing, or if you're dealing with like a turbine blades or windmill blades, and you might want to open up that a little bit. The larger the part, the larger the deviation. But again, keeping the entire design intent within the thought process is very important. Some of the changes that we see as well require a lot of modification to the part, because they're actually doing a design change. Like you have a final part that's being manufactured, but there's no math model, so they take apart, modify it, scan it in, and then basically build off of that final scanned-in part. So if there's tool marks, or if there's scratches, or if there's something on the final part that's undesirable, the scanner's going to pick that up. So we might have to deviate in those areas. So the word accuracy, or the term accuracy, is kind of a fluid term. You know, there's generalities, and then there's things that absolutely need to be held. So.
And some of the to build onto that, the as-measured data, the different kinds of devices have inherent error in them, and some can be increased. A portable arm, the newer ones are accurate to plus or minus 1,000 tolerance. If you put a scanner on the arm and you scan the data instead of using a hard probe, you are inducing probably about another 2,000 or 3,000 possible error. Laser trackers, if you take the data with a hard probe within 20, 25 feet, you can be accurate to 1,000 or 2,000. If you put a scanner attached to some of the laser trackers, you could change that to 5,000. Some of the handheld scanners are plus or minus 10,000. So all these different devices have different accuracies where they can gather the data. A coordinate measure machine is probably the most accurate way to take the data. It's just limited in size sometimes, unless they're really large, gantry style, and they're not portable. So all the different devices, that's kind of what the right tool for the right job. They all come with different kind of tolerance bands. And then, like Steve explained, inside CATIA, there's a lot of decisions that need to be made, cleaning the data and fitting surfaces through the scan data.
Thanks, Larry. I have a next question. Is there a CATIA solution for rotational molding?
For rotational molding? Well, there are. What part of the solution are you looking for rotational molding?
Oh, let's see if he asked me that.
Can we get a little bit of...
I do have another question while maybe that person is responding to your question. Mm-hmm. Once you have the surface scanned and or created, it is in its own coordinate system. Usually the surface, OML, exists. Do you have a way to align or best fit the scanned surface with the master OML surface already released in CATIA?
Yeah.
I could take, okay, go ahead, Steve.
You want to take this one, Larry? Okay.
No, go ahead.
I'll grab it. There's tools within like the digitized shape editor that, as Larry is probably going to mention, there's certain areas on the part that you can scan in as sort of locators. And even if you don't even have those locators, there may be holes or something that you can locate against to sort of take that point cloud and then fit it to the final surface. If there are no holes, if there's a sort of a boss or a defining feature that that you need to align things to, there's a complete set of tools within the digitized shape editor that allows you to take the point cloud and fit it to that locating feature. So if there's something that's rectangular in shape, circular in shape, or if there's something close enough to one of those shapes, you can take that point cloud, basically capture that area of the point cloud, and say transform it to the actual surface, and the system will do a fit based off of the inputs that you give it. Again, it's sort of a black art with the designer, because you have to be careful of one of the things that Larry mentioned is errant points, and you have to make sure that the data that you're using is relatively clean, and it actually does represent that shape or that part of the final product. But there is an entire suite of tools within digitized shape editor that does allow best fit and transformation such.
And then there are also in the different scanning software packages, they all come with best fit. They all have where you can take a point cloud and you can pick the part of the model that you want. You can weight different things, holes versus points, and you can align measured or scan data to the model. VeriSurf is very strong at doing that, and like Steve says, there's workbenches inside CATIA that also do that. Hopefully that answers your question.
Let's go back to, is there a CATIA solution for rotational molding? He's asking from a reverse engineering perspective.
Okay. With your, are you taking a, well, I'll answer as best based off of what I think the person wants. With the reverse engineering perspective, you're taking a part, you're spinning it to manufacture it. My assumption is that you have a part that's currently being made, and you want to be able to take that part and make a model of it, maybe make modifications of it to make a new part, or you want to actually physically check the data to make sure that the data that you are getting, or the final parts that you are getting, are to within allowables. So we'll take the first one. As far as reverse engineering, there are tools, scanning tools, that will allow you to scan something, I guess, in a rotational, sort of like on a tabletop, where I don't know what the range is, the angle range. Larry would probably know that better for me. Like if it goes from 0 to 180 degrees, or you know, since these are spun form, you could simply just take a section of the part and then do a final revolve, and then take those surfaces and measure them against a revolved, or the final revolved part, or the spun part. You know, if you want to work with curves, you can easily generate those curves from that point cloud. So you know, it's hard to sort of take a guess. I don't know what you're spinning, if you're doing a nose cone.
Steve, he did respond by saying that we build our own molds generally based on a 3D model and checking the data against the final mold.
Yeah, typically, let me help a little on that, Steve. Yep, on a revolve part, the best practice that I've experienced is exactly what you were saying. I take a cross-sectional cut of the part. Typically, I smooth the curve. It becomes a 2D curve. Then I smooth the curve, and then I revolve the curve about the axis. Okay. Now you have a solid model. You also then, in these different inspection devices with VeriSurf, we'll use VeriSurf for example, after you revolve the model, then you can go and you can build to your as-built model and validate exactly how accurate that you did it. So you might have picked a bad area. You might have picked a bad area of the 2D scan that you wanted to use. I hope that answered the question. So basically, on a rounded part with an axis, you take a 2D cross-sectional scan, clean the curve, smooth it, revolve it, and then you want to go back and you want to validate what you revolved matches the physical part. I hope that answers the question.
Okay, thank you, Larry. I'm not seeing, it says, do you use other CAD products other than CATIA?
Well, we at Adapt, Steve I know does a lot of modeling inside CATIA and Unigraphics and X. Steve, maybe you can talk about some of the advantages of some of the different packages that you experienced.
Of course. As Larry mentioned, I've used NX heavily as well for reverse engineering. The tools in NX are not as developed as they are in CATIA. They are pretty good. They do work better with, that I've found so far, with stereolithography parts. I know there's things like the Geomagics and so on and so forth, and some of these other tools like ISOM that have very powerful reverse engineering tools. ISOM is now currently owned by Dassault Systems as well, so those tools are being integrated into CATIA. I know there's ImageWare, which is the NX solution for pure reverse engineering, which also is very, very powerful, but it's not fully integrated as the reverse engineering tools are within CATIA, unless there's something that's changed recently. So there may be some translations and things of that nature that would have to take place. And if not, there's still some things within CATIA that it just, as far as I can tell, does better with the initial fitting of the surfaces, the projection of surfaces onto curves and points. There are other tools that build surfaces for you. You know, they say automatically build surfaces for you. What I found the problem with those is a lot of times it'll sort of facet the final result, where it takes 3 points, does a surface, fits it in, sort of like a fill, and then takes the next 3 points and does another fill, and takes the next 3 points and does another fill, sort of like a stereolithography, but there's a tangent, kind of a tangent continuity between the surfaces. So you end up with a surface that has 1,000 or 10,000 or 20,000 or 50,000 triangular little patches, and those, like, you know, they say automatic. I call them auto magic, because those auto magic tools really are giving you sort of like a warm fuzzy, but not actually giving you something with a high level of accuracy. I've worked with a lot of those like automatic surfacing tools in some of the design studios I've been, because they're really heavily dependent upon reverse engineering. And a large part of the issue comes in with surface continuity between edge boundaries of the surface. What ends up happening is as you go from one point to another point across those boundaries, there's a propensity for tangency and curvature continuities to be broken in order for the surfaces to join up. So if I have a vertex that has 3 or 4 surfaces coming to it at that singularity, then you end up with really bad edge continuities and things of that nature, because it's really hard for the algorithms to sort of smooth the surface across those points. Whereas within the CATIA suite, you have like the power fit, where you're able to go in, sort of parse out the data that you want, basically creating a part or a localized area within the data that you want to fit a surface to based off of a tolerance. And you can control the accuracy that you want, how tight it fits to those points, the level of complexity of the surface, and then quickly build the surface through those points or cut a section through those curves, and or cut a section through those points to get curves to fit the surface through as well. So the nice thing about the CATIA tool is that it gives you, as far as I've seen, more options than any other tool, because again, they adopted the ISOM workbench tools, and those ISOM tools within CATIA were historically the best tools out on the market. And then with the combination of what Dassault had to offer with the parametrically driven surfaces, with the parametrically driven solids, it sort of just wraps everything up into a nice product. I've used the other ones. I far prefer CATIA over everything else. It's not just a hard sell. It's experience of the past 15 years of putting up with a lot of the other tools. There's other tools like Alias. That's more for styling. The tolerances on Alias aren't really nearly as tight, or doesn't have the same level of technical capability that CATIA has. Honestly, truthfully, it's not just an opinion. It's from years of using those other tools that it does a better job as far as the reverse engineering. And with being able to scan those points and dump them in basically directly, you can take raw point data and basically do anything you want to with it. You can quickly. One of the nice features that we really didn't talk about here is being able to take a point cloud and make an STL out of it. Taking that STL and being able to quickly make like a plastic part, or grow a part out of one of this like STL manufacturers can make prototypes for you relatively quickly and easily. You can shade the part with the STL generated right off that point cloud. You can cut the sections. I mean, there's so many things that a person can do. It's pretty mind-boggling.
Well, along that line, I think you might have already answered this, Steve, but Peter is asking, is there any CATIA module that allows you to scan data directly into CATIA? And Kevin has offered that CATIA also has a MTD mold tool design workbench, which is very powerful.
It does. It has a mold design workbench. ImpactSoft makes a molding workbench that you basically type in, like you have a constant wall thickness, or you have a shrink ratio that you're able to apply. And then as ribs are being constructed, as holes are being put through, those basic rules of drafts and shrink and all that other things are automatically implemented and built and designed into the part. So those tools do exist, and they are very, very powerful. And what's nice is there is the history. So if I have a shrink ratio that goes from 0.7 to, say, 0.6 because you're changing materials and you don't want to get those lines across the A-side surface, then you can go in there, change the shrink ratio, and the ribs and walls and thicknesses will all accordingly adjust. And in most cases, if built with relatively clean modeling techniques, you can get 70 to 90% of the way there with literally a few pokes of the buttons and a couple of tweaks of the parameters. And that's, again, one of the nice things about CATIA is being able to take those points, import a text file or an ASCII file or any type of one of those files, or an IGES file, and dump it right into the digitized shape editor and filtering out the points, cleaning them up, and then making a parametric model based off of those points. Something that if you were to import a new cloud in, you can go to your parametric model, make the modifications to make it fit to the new cloud without having to completely redesign everything. CATIA is the only tool that I know that will allow that to happen with that level of parametric.
And to kind of answer the question on is there direct scanning inside CATIA, the only software that I really know of is Metrologique that can connect some of these digitizers directly to CATIA, but it's not really, it's not a reverse engineering tool. It's an inspection tool and software, so it's really designed more to attach an arm to CATIA live and to do a validation, model validation. and it's not really geared for reverse engineering. So it's a little overkill for that. And if all the benefits like Steve has mentioned that CATIA offers, which I think are many more modeling benefits than some of these other softwares like the PolyWorks or the Geomagic or the RapidForm, those products are great for hooking to a device, gathering the data, saving the data, and bringing it into CATIA. And then they also have other benefits as far as quality control and model validation. So it's, in my opinion, it's a very good combination to use a VeriSurf software and a FerroArm and a scanner, gather the data, organize the data, and then bring it into CATIA for the design engineer or the reverse engineer to model the data. Any other questions, Joni?
I think that is about it, Larry. I think you both answered them very well.
So the major three takeaways that I would really like to emphasize here is selecting the right tool for the job. Hopefully we explain that the importance is your downstream application. What is your purpose for measuring or scanning a part? What is your intent to do with the data after you scan it? So that determines what is the best tool for the job. What is the best digitizer, size-wise accuracy, what software you want to use, bring the data into CATIA. The second one is, where does CATIA fit in the process? Hopefully we explain that the result after you reverse engineer a part, you're going to get an intelligent solid model with history, parameterized, that you could use for other applications with all the other CATIA workbenches. And then what can I expect in terms of results from the process? Kind of the same thing. You're going to get an intelligent model, higher level of accuracy than some of these other tools, and many different processes that you could use that model for downstream applications. So I think those are the three main takeaways of modeling inside CATIA.